Hello, I'm Matthew from ScanTraining.com. My job is to assist Bobby in sharing information about scanning and other topics that will enrich your knowledge. Today, we are going to discuss accuracy confirmation. In other words, how do you know your scan data is accurate and that you can rely on the measurements for your reconstruction and analysis? The accuracy of any measurement is essential, particularly when the results may impact someone's freedom. Your ability to prove the accuracy of your scan data is vital for that reason. It's not enough to say your scanner has been factory calibrated. Calibration only confirms that your scanner was working as designed on the day it was serviced and calibrated. Shipping from the service center and day-to-day handling of your equipment could potentially affect the accuracy of the scanner's measurements. With this in mind, you should independently check your scan data on a case-by-case basis by using a simple point-to-point mathematical procedure. Using a known measurement standard within your scan is an excellent way to check the scan data accuracy. One recommended standard is a 4-foot scale bar for field use, that is traceable to an ISO-certified device. This device is inexpensive and can be confirmed and documented using your ISO-certified standard. Faro offers a calibrated scale bar using a certified measuring device traceable to the International System of Units through a National Metrological Institute and ISO 17025 accredited laboratory. Let's take a look at how we can utilize a scale bar for accuracy confirmation. Before you scan, place the scale bar within 10 feet or so of the scanner. Both ends of the scale bar should be visible. The scale bar should be placed perpendicular to the scanner when possible. Placing the scale bar too far away will make it difficult to see the corners and obtain accurate measurements. Placing the scale bar too close could put part of the scale bar within the void under the scanner, making it impossible to see. Place the scale bar in an inconspicuous location where it is easy to see but not the center of attention. Before going further, we should discuss how the scale bar works to confirm the accuracy of your data. By placing an object or scale bar with a known length within the scan area, we can measure that object in the scanning software and confirm its measurement. In other words, if you measure the scale bar in the software and the result matches the known length, we could say the data is accurate. But to prove the accuracy beyond a reasonable doubt, we need to evaluate the data by using universally accepted mathematical analysis. Let's start by discussing the mathematical theorem supporting our analysis. The Pythagorean Theorem, according to Wikipedia. In mathematics, the Pythagorean Theorem, or Pythagoras' theorem, is a fundamental relation in Euclidean geometry among the three sides of a right triangle. It states that the area of the square whose side is the hypotenuse, the side opposite the right angle, is equal to the sum of the areas of the squares on the other two sides. This theorem can be written as an equation relating the lengths of the sides A, B, and C, often called the Pythagorean Equation, which states that A squared plus B squared equals C squared, where C represents the length of the hypotenuse, and A and B, the lengths of the triangle's other two sides. In our application, we can use the Pythagorean theorem to identify the length of an object, such as our scale bar if we know the x, y, and z coordinates of 2 points, such as the beginning and end of the scale bar. Let's take a closer look. Open the Scene software. I'll wait a moment for Scene to load. Open a project containing a scan you would like to work with. Navigate to the Explore tab. In the structure view on the left side of the screen, locate the scan you are going to use. Select the scan. Right-click. Choose View. Choose Planar View. I'll wait for a moment for the scan to load. After the scan has loaded, locate the scale bar and adjust the view so you can see both ends. If the scan is in color, on the top menu bar click Color Mode, it should be the fourth icon from the right. The image should change to grayscale. Using the Mark Point tool, second icon from the right, click Mark Point. You should see a pushpin icon when you move your mouse into the viewing area. Carefully place the tip of the pushpin on the corner of the scale bar and click once. Rename the point AC1, this means Accuracy Confirmation Point 1. You may have to right-click on the point and choose Rename. Now mark the corner of the scale bar on the other end. Rename this point AC2. In the structure view on the left, click on the plus sign next to the scan name. This will expand the scan and you should see the 2 points AC1 and AC2. On the menu bar, 6 from the left, locate measure points. From the dropdown, choose Measure Objects. In the structure view on the left, click once on AC1. Next click once on AC2. Now press Enter followed by the Escape key. In the structure view on the left under the scan you are working on you should see measurements. If you expand it by clicking the plus on the left of the word measurement, you will see Measure Object. Right-click on Measure Object, and choose Rename and rename it Scale Bar. Review the results of the measurements to ensure you got the correct measurement. If not, zoom in close to the corners to identify which point may need to be replaced. Once you have the points placed properly, it's time to look at their properties and do some math. Right-click on AC1 in the structure view and choose Properties. Right-click on AC2 in the structure view and choose Properties. Align the property boxes so they are on the left side of the screen, with AC1 on the top portion and AC2 on the bottom. Click in the position box of AC1 and use the left arrow to expose all of the numbers. Do the same for AC2. The numbers will be displayed with the X value on the left, a space, the Y value in the center, a space, and the Z value to the right. Open your web browser, preferably Google Chrome. Go to ScanTraining.com. Log into your account. Go to More. Now go to Accuracy Confirmation Calculator. You may want to split the screen by dragging the browser window to the right side of the screen, then click on the Scene window. Scene should be on the left and the browser on the right side of the screen. This will make it easier to view the data from Scene and enter it into the Accuracy Confirmation Calculator. Fill in the fields at the top so you can save the results from the analysis. Input the values from the AC1 first. Be sure to enter any negative signs as needed. All of the math will be done for you in a step-by-step display. Check the final results against the measurement in Scene. You should also confirm the results with a calculator so you can be confident of the results. You can print or email the results. We hope you have enjoyed this tutorial. Please feel free to hit the like button and subscribe to keep up to date on the latest release. We invite you to check out CalcZonePro.com for your crash reconstruction calculations. Thanks again for watching.